Okay, a few important notes from yesterday's lesson in this podcast. This is problem number 47. It's a problem that we didn't look at as an example yesterday. We're going to look at a couple examples today so that you guys can finish the assignment here in class. It's the antiderivative of x squared times the square root of 1 minus x dx. And we are going to use u substitution to solve this. So what I'm going to do is I'm going to let u equal 1 minus x. We talked about how we should let whatever's underneath the square root sign be our value for u first, just to test it. And in this case, then, that would mean du, the derivative of u with respect to x, is going to be negative 1 dx. Okay. Now you might look at this and say, well, I don't have negative 1 dx, I have x squared dx that I need to get rid of. So there's a little trick to try and take care of a problem like this. Since I know that u equals 1 minus x, I can actually solve for the variable x in terms of u. And all I have to do is subtract 1 from u. So all I did is take this 1 and I subtracted it from this side to equal negative x. Which means that if I multiply by negative 1 on both sides, I get negative u plus 1 is equal to x. So now wherever there's an x in the problem, I can put in the value negative u plus 1, because that's what I let u equal. So let's rewrite this now. First of all, I want to get rid of this negative 1 dx, so I'm going to make this negative 1 in here, or negative x squared, so I have a negative dx on this side. If I do that there, I have to put a negative 1 on the outside. So keep that negative 1 on the outside. Negative dx is just du. X squared, well, x is now negative u plus 1, so we're going to take negative u plus 1, the value for x, and square it, times the square root of u, and we said that negative sign, negative dx, is really just du, so du. And now we just need to work out this antiderivative. So I'm going to FOIL this out quick, just to simplify it. It's negative 1 antiderivative of u squared minus 2u plus 1 all times the square root of u, or u to the 1/2 power, du. Okay, multiplying this u to the 1/2 power through the parentheses, to simplify this a little bit further, I get negative 1 times the antiderivative of u. Remember, you add the exponents here, so u to the 5/2 minus 2u to the 3/2 plus u to the 1/2 du. And now all that's left is to take the antiderivative of each of these individually. So I'm going to get negative 1 times, then the antiderivative of u to the 5/2 would be u to the 7/2 all over 7/2, or 2u to the 7/2 over 7 minus, antiderivative of this would be u to the 5/2 all over 5/2, or so we're going to multiply by 2/5, so I'd have 4/5 u to the 5/2 plus, then add 1 here, you get u to the 3/2 over 3/2. Now, division by 3/2 is the same as multiplying by 2/3, so that's what we have for our antiderivative. Resubstituting in the value for u, get negative 1 times the group 2. Since u was equal to 1 minus x, it's going to be 2 times 1 minus x to the 7/2 over 7 minus, and then I see I'm going to run out of time here, but we'd put 1 minus x in for u here and here, and don't forget at the end we'd add the constant c, and then you'd be done with that particular problem, problem number 47.